Hello dear students, I'm here with the second video for this chapter Haloalkane and Haloarene. In this video we are going to study nomenclature. So when it comes to nomenclature, we generally use two types of nomenclature, that is common name and IUPAC name. Common name is written as alkyl halide, whereas IUPAC name is written as haloalkane. So we have four halogen atoms: fluorine, chlorine, bromine, and iodine. So when we write the common name, the halogen is written in halide form. That means fluorine will become fluoride, chlorine will become chloride, bromine will become bromide, and iodine will become iodide. Whereas the halo name for the halogens, that is fluorine, will become fluoro, chlorine will become chloro, bromine will become bromo, and iodine will become iodo. So let us try to learn the common name and IUPAC name with the help of examples. So the first example I'm going to take is CH3Cl. So let us see the common name. So we know if we have one carbon, the alkyl name is methyl. So what name we'll write for this CH3Cl? Alkyl name will be methyl, and the halide name for Cl is chloride. So the common name for the compound CH3Cl is methyl chloride. Now let us see the IUPAC name. IUPAC name is written as haloalkane. So the halo name for chlorine is chloro, and the alkane name for one carbon is methane. So the IUPAC name of this compound, that is CH3Cl, is chloromethane. Let us take the second example, that is CH3CH2Br. So what is the common name for this CH3CH2Cl? Again, alkyl first. So if you have two carbons, what is the alkyl name? Is ethyl, E-T-H-Y-L, ethyl. And what is the halide name for Br? Is bromide. So it's written as ethyl bromide. Whereas the IUPAC name is written as haloalkane. So what is the halo name for Br? Is bromo. And alkane for two carbon is ethane. So name of this compound in IUPAC form is bromoethane. Let us take some more examples. CH3, CH, Br, CH3. Now, while writing common name, we use the prefix like an, iso, sec, tert, and neo. Now, N, when the halogen atom is attached to the terminal carbons. Iso, if it is 3 carbon chain, the halogen atom will be attached to the middle carbon. Whereas if it is 4 or more than 4, the compound where 1 degree followed by 2 degree is known as iso. For sake, if the halogen atom is attached to a carbon which is 2 degree. Third, if the halogen atom is attached to the carbon with 3 degree. Whereas neo, if the halogen atom is attached to a carbon which is 1 degree but is followed by 3 degree. So let us try to write a common name for this. So you can see here the halogen atom is attached to the middle carbon, so we'll use iso. So it's iso. How many carbons do you have here? You can see 1, 2, 3. So what will be the alkyl name? Propyl. So isopropyl. And what is the halogen atom? Br. So halide name will be bromide. So the common name for this compound is isopropyl bromide. Now let us see the IUPAC name. Now when we write the IUPAC name, we use number to represent the position of halogen atom. Now while writing the IUPAC name, we have to follow the IUPAC rules. Okay? So according to the IUPAC rules, we have to first look for the longest possible chain. So now let us see the longest possible chain. Here you can see there is only one chain. That is 1, carbon 2, carbon 3. Now next is to find out the lowest possible position for the halogen atom. So let us count from right to left. So if we count from right to left, this is carbon 1, this is carbon 2, this is carbon 3. So what is the position of Br? It's carbon 2. Now let us check from left to right. This is carbon 1, carbon 2 and carbon 3. So again you can see the position of Br is carbon 2. So whichever side we take, the position of Br is going to be carbon 2. So we'll write the name. We'll start with the position of the halogen atom, that is position 2. So we'll write 2 bromo, and since you have 3 carbon, the alkane name is propane. So the IUPAC name for this compound is 2-bromo-propane. Let us take the next example. CH3, CH2, CH, Br, CH3. Now in this compound, again the longest possible chain, 1, 2, 3, 4. So this is the longest possible chain. Now from right to left is carbon 1, carbon 2, carbon 3, carbon 4. Left to right, carbon 1, carbon 2, carbon 3, carbon 4. Now you can see if you go from right to left, the position of Br is carbon 2. Whereas if you go from left to right, the position of Br is carbon 3. So we prefer the lowest position. That means we'll go from right to left. So that means carbon 1, carbon 2. So what is the position of Br here? It's carbon 2. So we'll write 2-bromo-butane. So this is the IUPAC name. Now what is the common name for this compound? Now you can see the halogen atom. It is linked to this carbon, which is linked to 2 more carbons. So therefore this is 2 degree. So for this we'll use the prefix sec. So it's sec butyl bromide. Let us take some more complex compounds. So let us take this compound. We'll just try to write the IUPAC name since in exam they mostly ask the Haloarenes name. So for this compound, again let us try to find out the longest possible chain. So this is carbon 1, carbon 2, carbon 3, carbon 4. So if you follow this chain, you will have 1, 2, 3, 4 carbons. But if you go straight, 1, 2, 3, 4, 5, we will have 5 carbons. So which is the longest possible chain? The longest possible chain is having 5 carbons. So this is the longest possible chain. That means CH3 here will act as substituent. So what will be the name of this substituent? It is methyl. Since you have 1 carbon, is methyl. If you have 2 carbons in the substituent, is ethyl. If it is 3 carbon, is propyl, and so on. So this is carbon 1. Why this is carbon 1? Because we have Br, that is bromine. So this carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So what is the position of Br? Is carbon 1. What is the position of CH3? Is carbon 2. Now, which one to write first? Since we have 2 substituents, we will follow the alphabetical order. Now what is alphabetical order? You see here, bromo, it starts with B, whereas methyl starts with M. So when we check the alphabet, B comes before M. So while writing the name, we'll write bromo before methyl. So we'll write 1 bromo, 3 methyl, and since you have 5 carbons in the chain, it's pentane. So the RBC name of this compound is 1 bromo, 3 methyl, pentane. Let us see the next example. CH3, CH, Cl, CH2, CH2, Br. Now in this compound, you can see we have 2 different types of halogen atom, that is Br and Cl. So this will be carbon 1, carbon 2, carbon 3, and carbon 4. Now again, since we have 2 different types of halogen atoms, that means 2 different types of substituents, again we'll follow the alphabetical order. So Br means bromo, starts with B. Cl means chloro, starts with C. So when we go alphabetically, B comes before C. So we'll write Br before Cl. So what will be the name? 1 bromo, 3 chloro, and since you have 4 carbon, is known as butane. So the RBC name of this compound is 1 bromo, 3 chloro, butane. Next, CH3, CH, Cl, CH2, Cl. Now you can see in this compound we have 2 substituents but of same type. So if we have 2 substituents of same type, we'll use the prefix like di, tri, tetra, penta, etc. Di when we have 2, tri when we have 3, tetra when you have 4, penta if you have 5. So let's try writing the name of this compound. So this will be carbon 1, carbon 2, and carbon 3. So when we count from right to left, the position of Cl are 1 and 2. But if we count from left to right, 1, 2, 3, it will be 2 and 3. So we prefer 1 and 2. So we'll count from right hand side, 1, 2, 3. So you have 2 chlorine, one is at carbon 1, other one at carbon 2. So this is written as 1, 2. This 1, 2 represents the position of Cl. That means one Cl is at carbon 1 and the other one is at carbon 2. So 1, comma 2. Since you have 2, we'll use the prefix di. So 1, comma 2, di. What is the name of this? It's chloro. So it's dichloro. How many carbons do you have in the chain? It's 3. So it's propane. So what is the RPC name of this compound? 1, comma 2, dichloropropane. Next example. You can see here, this is an aromatic compound, and the name of this aromatic compound is benzene. So what will be the RPC name for this compound? It's chlorobenzene. You can take some more compounds from the textbook and you can practice the nomenclature. So next we'll see the preparation of haloalkane. So haloalkane, it can be prepared from different types of compounds. Different types of compounds with different functional group. We can prepare haloalkane from alcohol, we can prepare from alkane, we can prepare from alkene using different types of reagent. Okay, so we'll start with alcohol. So from alcohol, there are different types of reagent which is used, like PCl5, halogen acid HX, PCl3, PBr5, PBr3, then SOCl2. So we'll take the examples of all the reagents and see how we can convert alcohol to haloalkane. So let us take the first reagent, that is halogen acid. That is HX, where X is F, Cl, Br, or I. So let us take a reaction, that is ROH. So we know compounds with functional group OH is known as alcohol. Where R, it can be any alkyl group like CH3, C2H5, C3H7, etc. Plus, we'll take the halogen acid, that is HX. In presence of anhydrous zinc chloride. Now, this anhydrous zinc chloride is very important. In absence of this, the reaction will not take place. Now, why is it important? This anhydrous ZnCl2 will help in breaking the carbon-oxygen bond, so that OH is replaced by X. So, it's a very simple reaction. The alcohol having OH will be replaced by X. So, we'll get RX. Plus, this hydrogen will go with OH. That is, acid with base will form H2O. Let us take an example. C2H5OH plus HCl in presence of anhydrous zinc chloride. Now here, the alcohol is known as ethanol. Why ethanol? Because you have two carbons. And we know when we write the nomenclature for alcohol, the alkane, in alkane, E is replaced by oil. Say you have two carbons here, so what is the alkane name? It's ethane, E-T-H-A-N-E. So since it's alcohol, E is replaced by OL, so it becomes ethanol. What is the name of this halogen acid? It's hydrogen chloride. Now when ethanol reacts with hydrogen chloride, the product form will be OH replaced by Cl. So you'll get C2, we get C2H5Cl and water. So the name of this compound is chloroethane. Let us take one more example. So here the alcohol is cyclohexanol. So when cyclohexanol reacts with HCl, it will form cyclohexyl chloride. And water. So next let us take the second reagent, that is phosphorus pentahalide, where X can be Cl or Br. In some cases we can also take I, that means Pi5. So let's start with this reagent. Let us take an alcohol, that is ROH plus PX5. So here OH is replaced by X, so we get RX, plus we'll get a halogen acid HX, and we'll get phosphorus oxychloride. Let us take an example. C2H5OH plus PCl5. The name of this alcohol is ethanol. Reacts with phosphorus pentachloride. So when ethanol reacts with phosphorus pentachloride, OH will be replaced by Cl. You can see in this reaction, OH is replaced by X. So in this reaction, in place of X, you have Cl. So OH will be replaced by Cl. So you will get C2H5Cl plus. But Cl with H will form HCl plus will get POCl3. Sorry, this will be POX3. Let us take one more example. So here in place of X you have Br, so OH will be replaced by Br, so we'll get this product plus HBr plus POBr3. Let us take the third reagent, that is PX3. So when we take PX3, ROH reacts with PX3. Again, OH will be replaced by X. So we'll get RX. When we take PX3, instead of halogen acid and phosphorus oxyhalide, we get only one product, that is POH3. Or we can also write it as H3PO3. Let us take an example. C2H5OH, name of this compound is ethanol. If it reacts with PCl3, the compound form will be C2H5Cl plus H3PO3. Second example, we have this compound CH3, CHOH, CH3. The name of this compound is propan-2-ol. So if propan-2-ol reacts with PBr3, phosphorus tribromide, again here OH will be replaced by Br. So you'll get CH3, CH, Br, CH3. And name of this compound is 2-bromopropan. and the side product will be H3PO3. Next, let us see the fourth reagent, that is SOCl2. SOCl2 is known as thionyl chloride. So let us see what happens when thionyl chloride reacts with alcohol. So let us take this alcohol in general, that is ROH plus SOCl2, that is thionyl chloride. Now when alcohol reacts with thionyl chloride, OH will be replaced by Cl. So you will get RCl plus you will get halogen acid, that is HCl, and you will get sulfur dioxide. Let us take an example. CH3, CH2, CH2, OH. Name of this alcohol is propanol. So propanol, if it reacts with SOCl2, the product form will be CH3, CH2, CH2, Cl. This is the main product, that is 1-chloropropane. And the side products HCl and SO2. That is hydrogen chloride and sulfur dioxide. Let's take one more example. So here also OH will be replaced by Cl. So this is how we convert alcohol to haloalkane using 4 different reagents, that is halogen acid, phosphorus pentachloride, phosphorus trichloride, or phosphorus pentabromide, phosphorus tribromide, and thionyl chloride. So let us see the next preparation of alcohol using alkene. So before we start the preparation of haloalkane using alkene, let us try to know the different types of alkene. There are 2 types of alkene, that is symmetrical alkene and unsymmetrical alkene. I'll explain with the help of an example. So let us take this alkene, CH2 double bond CH2. Now you can see in this alkene, the carbons forming double bond have equal number of hydrogen. So if in an alkene, the carbon forming double bond, if they have equal number of hydrogen, the alkene is known as symmetrical alkene. One more example, CH3, CH double bond CH, CH3. This is but2ene. So in this alkene, you can see these 2 carbons, that is carbon 2 and carbon 3, they have double bond between them. And each of the carbon have 1 hydrogen. So therefore, this is symmetrical alkene. Whereas if you take CH3, CH double bond CH2, this is propene. And here, the carbons forming double bond. So these 2 carbon, carbon 1 and carbon 2, they have unequal number of hydrogen. This carbon has 1 hydrogen, this has 2 hydrogen. So therefore, this is an example of unsymmetrical alkene. So in case of symmetrical alkene, the preparation of haloalkane is very simple. It can be either prepared by addition of halogen acid or by addition of halogen. Whereas in unsymmetrical alkene, to find out the major product, we have to use 2 different types of rules. That is Markovnikov rule and anti-Markovnikov rule. And this anti-Markovnikov rule is also known as peroxide effect. Now, if it is just the addition of halogen acid, we will follow Markovnikov rule. But if the addition of halogen acid is in presence of peroxide, we follow anti-Markovnikov rule. And since we use peroxide in anti-Markovnikov rule, is also known as peroxide effect. So let us start the preparation of haloalkane from alkene. Addition of halogen acid, where X can be Cl, Br, or I. So let us take an alkene, that is CH2 double bond CH2, and the name of this alkene is ethene, ETHE and E. HBr, hydrogen bromide. Now when we add HBr, hydrogen bromide, to ethene, one of the carbon will take hydrogen and the other carbon will take Br. So this pi bond will be removed and both the carbons will get H and Br. That means one of the carbon will get hydrogen and the other carbon will get Br. So what is the product form? CH2 single bond CH2. So say this carbon gets the hydrogen, this carbon will get Br. So this we can also write it as CH3 CH2 Br. The name of this haloalkane is 1-bromo-ethene, or we can simply write bromo-ethene. So let us take the example for an unsymmetrical alkene. So this is an unsymmetrical alkene. We'll be adding this halogen acid to it, that is HBr. Now here, since it is an unsymmetrical alkene, we are going to follow Markovnikov rule. Now why Markovnikov rule? Because we are not using peroxide here. So according to Markovnikov rule, the negative part of the molecule to be added, so if we see HBr, the negative part will be Br and positive part will be H. Now why Br is the negative part? Because Br is more electronegative than hydrogen. So Br being negative is added to the carbon having lesser number of hydrogen atoms. So if we compare these two carbons, this carbon has lesser number of hydrogen atoms. So if this carbon gets the negative part, this carbon will get the positive part, that is H. And the product form will be major product. So it's CH3, CH, Br, CH3, that is 2-bromo-propane. And this is major product. In case if Br goes to the carbon having more number of hydrogen atoms, the product form will be CH3, CH2, CH2, Br. That is 1-bromo-propane. And this is minor product. Let us take one more example. So here also you can see there is no peroxide, so we'll follow Markovnikov rule. Now these two carbons, they're having double bond between them. Now, if you see this carbon has got no hydrogen. This carbon has one hydrogen. So according to Markovnikov rule, this carbon will get the negative part, that is Cl. So the major product form will be CH3, C, Cl, CH3, single bond, CH2, CH3. And name of this product is 2-chloro-2-methyl butane. Now let us see the example for anti-Markovnikov rule. So you have this alkene that is unsymmetrical and we are adding HBr. And this reaction, it takes place in presence of peroxide. So since this reaction takes place in presence of peroxide, it will follow anti-Markovnikov rule. So according to anti-Markovnikov rule, the negative part will be added to the carbon having more number of hydrogen atoms. See, Markovnikov negative part goes to the carbon having lesser number of hydrogen. So anti-Markovnikov, anti means opposite. So in anti-Markovnikov rule, the negative part will go to the carbon having more number of hydrogen atoms. So the major product formed in anti-Markovnikov rule is CH3, CH2, CH2, Br. That is 1-bromo-propane. And the minor product formed is CH3, CH, Br, CH3. That is 2-bromo-propane. So if you compare Markovnikov and anti-Markovnikov, you'll find the major product in anti-Markovnikov will be minor in Markovnikov, and the minor product in anti-Markovnikov will be major in Markovnikov. Thank you so much. That's all for today. We'll continue this chapter in the next video.